Welcome to radar system course. We start here with the navigational aids of radar there. So what are the operation of radio navigational aids that we will learn here? And that navigational aids depends on the wave characteristics or a radio wave characteristic. So to understand a navigational aids, we need to know about what particular frequency bands of a signal available for the navigational aids, and before understanding the frequency band, we need to know about that waves generated by the antenna that waves are propagating in a space or in a ground there, or propagation takes place from transmitter to the receiver. When we send a signal from the transmitter to the receiver, so what happens? Your signal will be transmitted. Okay, your signal will be transmitted. So at the end we have a receiver here. Okay, so then that receiver getting the signal. So if you are communicating from one transmitter to the another here, okay, so in that case we are transmitting as well as receiving the signal from one to another device. So this part is, or this particular portion is nothing but a radio waves. That radio waves propagating from the transmitter to the receiver. When it's propagating from the transmitter to the receiver, that radio waves may be reflected from a conducting medium, means reflection occur whenever we have a surface, it will be a conducting one, so reflection will occur. So we can say that your signal will get reflected. Okay, so we can say that there will be a reflection because of a signal uh, reach or your wave is propagating in between. If any conducting medium arises, so signal will be reflected from that. Okay, then some of the time we can say that when your wave is propagating from one end to another end, so in between there is a medium. Okay, so in that case, that medium your signal is propagating, means there will be a refraction. Okay, signals will be refracted from, or you can say that a passing from a given particular medium there. So for example, we say that from ground to sky communication. So we have a atmospheric condition or a density, atmospheric density. Your signal is propagating from a ground station to the sky or to a satellite there. Because in the atmosphere there is a different ionization density. So that's why in a daytime and in a night time that density decreases or increases there. And that will be depending upon that what will be the sun rays propagating or focus on that particular ionization there. That ionization layer changes. So when we are propagating the signal from the ground to the satellite, so then there will be the issue regarding some particular frequency band. So signal, if that signal is passing through the given medium, so then we can say that the signals are refracting from the given particular medium there. Now sometimes what happens, we have a signal propagating in a medium, and then what happens, that wave will bend. Okay, so or we can say that some medium is there when the signal is propagating, so it will be bent toward the given particular direction. Okay, so why this bending occur at a boundaries, or at some particular medium, so signals may be reflected. Okay, so that's why we can say that there will be a deflection or diffraction occur, or signal may be propagating in a different direction at a boundary of a medium. So means your wave is not propagating through a given particular medium, because this medium has a different density, this medium has a different density, so refraction coefficient of a medium will be different. So that's why at a boundary of a medium your signal is propagating or reflected back. That's why we can say that what will be the refractive index of the particular medium there, or so that your signal will be refracted or it will be reflected from the given particular medium. Then another factor of a wave, when your wave is propagating, so then what happens? There will be the attenuation. Okay, so we can say that attenuation within a particular medium, because when it propagating through the medium, so your signal will be attenuated from the given particular medium, and then attenuation is depends upon the what will be the medium constant. So what are the medium constants? So medium constants are nothing but what will be the conductivity of a given particular medium. Okay, so we can say that conductivity, then what will be the permittivity and a permeability here. So we need to know about this particular constant. Okay, sigma mu epsilon, sigma conductivity, mu is your permeability, epsilon is nothing but a permittivity. So from the given particular medium, your signal is propagating, whether the medium having the highest conductivity, then it will be reflected there. Okay, or it will not penetrate through the conducting medium. Signal will not penetrating through the conducting medium. So we can say that a signal or your wave, when it propagating, so in that case that medium have a constant, and that medium constants are depends upon the conductivity, permeability and a permittivity. So when your wave is propagating through the given medium, so frequency of the wave propagating through the medium, that will allow to pass the your wave, or that will reflect the wave, that will attenuate the wave, that medium will attenuate the wave, or that wave will be refracted through the given particular medium. So while understanding a radio wave propagation, we should know that what are the various factors for the various wave propagation there. So generally a wave propagation exists in terms of what your wave is propagating on a ground there. So we can say that a ground wave propagation system. Then or we can say that a wave is propagating through the space. So in that case we can say that a space wave propagation, or we can say that a wave propagating in a sky. Okay, so we can say that a sky wave propagation. Okay, so we can say that we have a wave propagation, so sky wave propagation, ground wave propagation, and a space wave propagation. So these are about the wave propagation. So now each and every wave propagation, so there will be some band of a frequency, so that your wave is propagating here. So if you consider that a ground wave propagation, so in that case your wave will be what, a very low frequency band, or we can say that LF, or we can say that it will be a medium frequency, and that medium frequency we can say that it will be up to 3 megahertz. Okay, that's why you can say that wave, it is called as a ground wave propagation. Then in the case of a space wave propagation, your wave will be what, in the band of a HF. We can say that it will be from 3 to 30 megahertz. Okay, that is about the band of a propagation. In that case, we say that it will be the a space wave propagation. Then this one, okay, 3 to 30 megahertz, it is not, it will be for the sky wave propagation. Then we can say that what will be the wave propagating in a space there. So in that case, we have the VHF band. Okay, we have the SHF band out there. So through that, wave is propagating. Okay, so we can say that we have the VHF band, SHF band, and the EHF band, and here wave is propagating in the given particular band, that will be called as a space wave. Okay, so now this band is useful for propagating the signal to the satellite. In a satellite communication, if you see that this particular band of frequency is to be used, and along with that, we can say that a signal propagating from one transmitter to another end. Okay, one end to the another end. So if there are the two towers, one tower and another tower, so propagation takes place from one tower to the another tower, and that propagation is called as a line of sight propagation. But the condition is that the distance between these two devices, that is transmitter and receiver, is to be below 50 kilometer. If it goes beyond the 50 kilometer, so line of sight propagation will not be take place, wave will be attenuated because the earth is curved here. Because of the earth curvature, so we could not go beyond a 50 kilometer of a frequency propagation level. So that's why we can say that this kind of a propagation, okay, we can say that one end to another end. So that will be propagating, that is called as a line of sight propagation. Okay, so you can say that that will be a line of sight propagation. And in this case, signal will be transmitted from the one end to the another end, or signal will be propagating in a sky and then it will be reflected from the sky there. Okay, so likewise that will be the propagation. So you can say that there will be the ground wave propagation as well as the sky wave propagation there. Okay, so we can, so through that we can propagating the a signal there. So we can say that in a signal propagating in a space, there is ionization layer, so it will reflect the signal. Okay, likewise. So we can consider the a ground wave propagation, a space wave propagation, as well as a sky wave propagation. So all the factors propagation based on the a frequency. So which particular frequency bands of a frequency, okay, so your wave is propagating in a given medium. So that's why wave has some characteristics, and that wave characteristics based on the in which medium your wave is propagated. So that's why we should know that what are the medium constant. So these are nothing but the medium constant, and based on this medium constant, your wave is propagating in a different medium. Okay, whether it will be sky or whether it will be a space wave. Now, in a navigational aid, okay, so what are the various navigations to be considered there? So we will consider here a first navigation technique that will be useful by the radar or a radar navigation system. So in which we can say that one system is called as a instrument landing system. Instrument landing system, and that is called as a ILS. And this one is useful in a aircraft navigation. Okay, so we have the mostly a radar is used for the warfare, or we can say that for the uh, for the landing of a aircraft and all. So that's why we can say that this one a landing system. This one is a landing system. You can, that's why you can say that instrument landing system that will use a aircraft to land properly on a terminal there. Okay, so even if there is any weather condition means what? We can say that high storm, high rain, okay, heavy rain and all. So even in that particular condition, this instrument landing system will work. So that's why aircraft will land properly there. So we just use this a instrument landing system ILS. So that will be for the aircraft landing in any weather condition. So we can say that any weather condition is what, in a day or in a night, or in a, we can say that any weather condition. So if the visibility is low because of a heavy rain, okay, so we could not, that aircraft is not able to see the what will be the runway, okay, where will be the runway. That landing system that will provide you the knowledge of the a landing system. So that's why we can say that it provides, that instrument landing system provides a navigation for the pilot of a aircraft to land a your that aircraft on a runway. Okay, even if the weather condition is bad there. Now then, what are the component of this ILS system? So ILS system, it has a localizer signal, then a glider slope signal. Then we can say that it has a markers beacon. Then we can say that it has a light there. So these are the components are present in the, these are the various components of a ILS system. We can say that it has a localizer signal. So, and that localizer signal will provide you the information regarding the azimuth angle. Okay, so we can say that this localizer signal that will be useful for providing the information regarding the azimuth angle. So this one we can say that a azimuth angle there, or we can say that a information regarding the where is the center line of a aircraft. Okay, so we consider this particular signal to be propagating through this ILS system, and that a signal is in the range of what, 108 megahertz to 111.95 megahertz. Okay, so this one is about a localizer frequency signal. So it has a 108 megahertz to 119.5 signal, 95 megahertz signal frequency there, and that will propagate the signal, and that will use to find out or use to guide the aircraft to the center line of a runway there. Again, this particular localizer will provide the signal, and that signal will display on the display device. Means localizer, whatever the information they are getting from the given particular signal, that information will be displayed on the a display device itself. Means this one ILS system has a indicator or a display device. So it will provide you the condition, or it will provide you the location of a runway, or a what is the position of a runway there, to so that a pilot can land the aircraft properly there. So then we have the a signal propagating, and then it will provide you the information there. So in that case we can say that what will be the portion of the signal within a particular region or a particular area that is to be propagating here. So area covered by this localizer signal, that will be of a distance of a 35 kilometer. Means we can say that a signal propagating through this a system, that or a localizer signal, when it propagating, so it use a distance of a 35 kilometer, and that localizer has a channel, not a, it is about a distance. Okay, and that's about a 35 kilometer of a distance when we send a signal. So when we can say that a action is to be taken place, in that case it will provide the information from the 35 kilometers there, so that a landing will be proper there. And there are the various signals to be propagating. So we can say that it will use to land not only the single aircraft. So that's why we have a various channels are there. So that's why we can say that there, every localizer, their channel width is about a 50 kilohertz. This one is about a localizer. Then a glider slope signal. Here is about, it will provide you the information regarding the runway, and then a glider slope signal that will provide the information about a vertical guidance. So this one is about the azimuth angle, or you can say that a horizontal information. Azimuth angle means what? So if you consider that a ground system, okay, the signal route right now supposed to be, we consider this one is about the antenna here, okay, and this one is about the aircraft. So it will provide the information regarding what a azimuth. Okay, so this one is about the azimuth information. Okay, so or you can say that a horizontal information. So what will be the position on a ground? So whatever the information regarding a ground here. So that will be provided by this a localizer signal. Then a glider slope signal that will provide say a vertical guidance. Okay, so this one is about a horizontal one. Okay, so this one is about a vertical guidance regarding the aircraft landing. Okay, so that signal transmitted from the runway. Okay, so that will be available at the aircraft. So glider slope signal that will provide the information regarding the vertical guidance. Okay, so we can say that in that case, uh, how much will be the projection? Okay, and that the projection angle, or you can say that is about a glider path. And then that glider slope signal, it has a channel width of a 150 kilohertz, and this one will be operating in a 329.15 megahertz to 335.0 megahertz. This one is about a range. Okay, so it will provide a information vertically. So when we talk about that a vertical information, so generally that a glide path projection, it is to be adjusted above the horizontal. Okay, so this one we can say that a azimuth we are getting information. So we supposed to consider that the information regarding the given particular a glide path projection angle. So that will be from the a horizontal. Okay, so that this way we can that glider slope signal is to be used there. Then a usable distance for this glider slope, that will be about a 20 kilometer, and this glider slope signal is more sensitive there, and that will provide a information regarding the what will be the position, and that signal, vertical signal as well as a horizontal signal, that will be compared to this a localizer there. And then what happen? So particular signal is generated, particular signal will provide you the regarding on a display. So what will be the horizontal position and what will be the vertical position? So at according to that, so it will provide a information uh, about the aircraft. So how it will provide the information? Because the antenna sends a signal. Okay, so this one we can say here. This one is about a glide slope. Now glide, you can have a glide slope there, and then it has a two different markers. Okay, so this one is about a information regarding the. Okay, so we can have the information here. So then we have the localizer too, and we consider the information. This one is about a glider slope. Then we have a localizer here. Then a localizer will provide the information regarding the what will be the a position. Okay, so supposed to consider this way so that we are able to understand what will be the a position. So there are the markers beam as well as a we have the outer marker. So then there is a marker beam. So in that case, there will be the a marker. This one we can say that a middle marker, and then another marker here, and this one is called as a outer marker. So there are the a two markers. One is about a middle marker and another is about a outer marker. So means it will provide the information regarding what will be the a glide slope. Okay, and from this glide slope it will provide the that outer marker as well as a middle marker. So if you consider the outer marker, in that case the sensitivity of a glider slope is about a 50 feet, and at the position of a middle marker. So position of that middle marker, in that case it will be of that position will be of a 8 feet. So means that information, that range information, that will be provided by the outer marker as well as a middle marker, and that information will be useful for the a landing here. And again, means we have these three signals. One is about a localizer signal, this one, that will provide the horizontal information, vertical information. Then these are the markers, will provide you the information regarding the what will be the length and all. And then that is about a 50 feet or a 8 feet distance. Okay, so likewise. But again, the approach light is there, so that whatever the nearby uh, runway, okay, in a nearby runway, there are the lights, and that approach light, that will provide you the information regarding the where is the a runway there. Okay, so in that case, means while landing the aircraft, we need to know about what will be the center line of the center line of this particular runway, and then at what particular center line or at what particular uh, position that aircraft is to be landed. So means touching this particular center line, okay, and then be in between the what will be the whatever the runway lights are available. So in between at this particular center, so nose of that particular aircraft is to be touched here. Okay, center of that wheel. Okay, it is to be touch at the a center line there, and then we have the a marker beacon here. Okay, so you can say that, and that marker beacon is useful for the what will be the altitude here. Altitude means what you can say that a localizer signal is providing you the lateral information, and then what this one is about a marker beacon are useful for the what will be the information in terms of a altitude. So this one is useful for checking the what will be the altitude there. Then we have this decision regarding whether to land the aircraft or not. Okay, that decision of landing the aircraft, that will be taken by the pilot based on the values from the a glider slope that will be determined by the altimeter there. Okay, so in general, we have a ILS landing system that will be useful for to land the aircraft even if any weather condition. And then we have this component of ILS, mostly we can use that is about a localizer. Then we can use a glider slope there. Okay, we can use a we can have the information regarding the uh, that a beacon thing. Okay, marker beacon. So generally we say that a localizer signal provides a information regarding the azimuth angle. Okay, so this one is about a localizer. So in that case, we will get the information regarding the azimuth, and then it will guide the aircraft to the center line of the a runway here. Means we are getting, means aircraft is getting the information regarding the what will be the a runway there. So means center line. Okay. So what will be the information? So we can say that a runway information that will be obtained or that will be provided by this localizer as well as a glide slope here. Okay, so we can say that we have the information regarding the a runway and all, and then we can consider that information is to be displayed, and that information is available to the pilot, and then based on that a pilot uh, is going to take the action regarding that at what particular position a aircraft is present, and according to that a landing is to be takes place there. So we have the two information. One is about a localized signal. We have the a glide slope signal there, and then we have these two particular signals operate at a different frequency. So we have already said that localized signal is used a band of 108 megahertz to 11.95 megahertz, and it has a channel width of a 50 kilohertz already we say, and glide slope signal that is useful for the vertical guidance, and that signal is transmitted from the a side of a runway, and then we can say that these are nothing but the a side of a runway. That will be signal is to be sent from the a side of a runway, so that it will provide the information regarding the central line of a runway here. Okay, and these are the markers. We can say that inner marker we have, then we have outer marker. Generally, a a marker that is that represents a light there. Okay, or we can say that our particular position, and that marker will provide you, so what will be the a height in terms of a feet. Okay, so or you can say that that will be a particular signal will provide you the information regarding the how much will be the height of the aircraft there. So mostly we can say that in terms of a feet, if it is the inner marker, if it is the outer marker, so in that case we can say that it will be in terms of a nautical miles. So what will be the distance, okay, from the runway to the aircraft? So in terms of a nautical miles. So that particular signal, and then from that auto marker, so signal will provide you to the decision regarding that from this outer marker to the a middle marker regarding the how much will be the distance. So in terms of a feet here, so that will provide you the information to the operator or a pilot to land the aircraft. So this one is nothing but a instrument landing system. So in instrument landing system, so approach light, a localizer, then a glide system. Okay, glide slope signals are used as well as a markers are used. So next, navigational system, we consider here the distance measurement equipment. So we can say that a DM here. Another system we consider, this one is about a distance measurement equipment. Okay, so we can say that this one is called as a DM. Okay, so the another approach. So that is again ILS is again useful for the a navigational one. Okay, aircraft navigation. Again, a distance measurement equipment. It is again useful for the navigational system. Okay, or we can say that a aircraft land likewise. So to provide the information to the aircraft, okay, that will be done by this particular DME. So then we can say that it will useful for what, measure the distance here. Okay, so we can say that we have a transmitter here. Okay, suppose we can say that this one is about a transmitter and this one is about a aircraft. Aircraft is able to find out the distance from the what will be the position of a device here. So generally a device is placed, okay, and then it will provide you the distance between the what will be the distance from this airport to this sorry aircraft to the airport. Okay, so likewise, so mostly we can consider that a measurement of a distance, and mostly this distance measurement equipment that will used at a air airport. So distance between the transmitted signal, okay, so sorry, distance is obtained, distance between the aircraft and a DME that will be obtained through the whatever the a transmitted signal. So that's why we can say that a distance measurement equipment, it consists of a ground beacon. This one is about one particular signal. Then it has a transponder, at a ground system. Okay, then we can consider that airborne transmitter. Okay, so that is at a that will be useful for the transmit and receive signal. Okay, so then we can say that a interrogator. Okay, so we can say that these are about the component of this distance measurement equipment. If you see the block diagram here, so generally what happens, so it has a in a aircraft, so then it has a transponder there. Okay, so we can consider the a ground based system as well as the system present in a aircraft. Okay, so in aircraft, the both it has a transmitter as well as the receiver. So that's why you can say that a airborne transmitter as well as a receiver. Okay, so it is present in a aircraft, and then a ground system. Okay, ground system it has a what both. Okay, it has both a transmitter as well as a receiver, and then the signal transmitted from the ground system. Okay, that is about a ground beacon thing. Okay, so then we can say that a signal transmitted from this ground system to the aircraft, and that will useful for the measuring the distance between the that this DME and a aircraft. So means we can say a transmitted signal between a aircraft as well as a in a DME, that is through the ground beacon, so that we can obtain the distance of the aircraft from the that DME. Okay. So generally we can say that a DME consists of this particular component. Okay. When we can these components are, if you see in a block diagram, so we have a various blocks of a DME. In a DME, we can consider that this one is a transmitter. Okay, we'll write in a different way here. This one is about a transmitter. Then we can say that a receiver, and then in between that there is a air now. Okay, so we can say that air channel, and then we have, okay, so this one is about a portion that is connected or that is available in a airport aeroplane. We can say that we have the airborne transponder. So transponder means it has a, both the action transmitting action as well as a receiving action is to be taken place by this one. You can say that this one is about a receiver, signal is received by the receiver, and then we have a DME. Okay, so in a DME we can consider there is a receiver. This one is about a receiver. Then here we have transmitter. Then we have a timing circuit. Okay, timing circuit there that will provide the information, and then this one is about a distance. Okay, so this one is about distance display. Okay, some display here. So now this one is a part of the aircraft transmitter as well as a receiver. We can say that airborne transmitter there, and this one is about a ground based system. Okay, so or you can say that a ground based interrogator. Okay, this one is about a ground based interrogator. So generally we can say that this particular system, okay, this one is at aircraft and this one is at a ground based system. So it transmit, okay, it transmit is some particular signal. So that's about a transmitted signal, or you can say that a pulse. Okay, so signal is transmitted. So means ground-based systems send one particular signal, okay, that is called through the interrogator. We can say that interrogator pulse to the aircraft. Okay, so aircraft we have a transponder. So then it receives the signal. The aircraft will receive the signal and then transmit back to the a ground beacon again. So that's why aircraft again transmit the signal to the receiver, and then a time taken by the transmission and reception that will be measured at a ground based system, that is called as the DME, and this time is calculated, or this time is that transmitting time as well as the receiving time is to be calibrated, and that will be displayed what will be the transmission time as well as the what will be the distance between the DME and the aircraft. So this one is the ground system. So on a from a ground we can find out the distance between the aircraft and a ground beacon. Okay, so we can say that. So in that case, generally we define what will be the range from the DME system, okay, to the uh, your aircraft. So that's why we need to know about the what will be the timing, okay, at what time that signal is to be transmitted. In that case, a total time minus a time delay, that is all in a microsecond, 12.36. So we'll get the uh, information in a nautical mile. So that range will be calculated in terms of a nautical mile. So generally it is used to measure the a distance there. So mostly it operates in 960 megahertz to 1215 megahertz. Okay, so you can say that 960 to 1215 megahertz of a signal frequency, and it measures only the a distance there. So it is just used to display what will be the distance between the aircraft and all, and a it operates this DME system. Okay, so it will consider 100 aircraft to be measured by this particular DME system. Means we can say that a DME system is used by the 100 aircraft at a time. So, and the operational range of a DME system is about a 350 kilometer. Mostly the range depends upon the aircraft height. Okay, so what will be the aircraft height is there from the whatever the ground system. So that's why a 350 from a 350 kilometers of a length. So it will observe a what will be the position of the aircraft from this transmitter to the receiver. So generally, if you consider here, so interrogation pulse is sent. Okay, so then interrogation pulse will received at the transponder of the aircraft there. Then interrogation pulse is detected at the receiver. Okay, and then pulse again generated here, and the same pulse is transmitted. Okay, so here we have a delay. Delay in between what? A transmitting pulse to be received at this particular place, that is about time transmitting to the receiver, and delay in between a transmitting to the receiver again DM, and then that pulse is generated, that will be there will be the delay generate a pulse, and then it is to be a transmitted and then research. So that's why it is called the total time, and we need to find out the delay generation of the pulse, that is about a delay, and from this we can find out the what is the range. It will mostly use as a navigational aid for the aircraft, for the distance measuring device, and it will use for the navigation. So that's all about a DME system. So with this we stop here.